So the last topic is additional topics number 7, normal distributions. So have you guys heard of the bell curve before? Yes? So the bell curve is used when we talk about like real life problems. So we could talk about the heights of all the women in the United States. The mean would probably be, I don't know, like 5'4" or something. And then you could talk about the standard deviation. Standard deviations are just numbers that mathematicians use to talk about what percent of a value is between. So like if I have my, let me draw it. If I have my bell curve, so here's my mean. The mean is the average value. We use mu, a little fancy M. Okay, if I was talking about 2 standard deviations away, that's 2 this way and 2 to the left as well. That would be 95% of your data would be within 2 standard deviations. If you talked about 1 standard deviation away, so 1 to the right, 1 to the left, that would be like 68%, so somewhere around 68%. All right. Okay, we have a chart. We're going to use this chart a lot. It's not going to make much sense right now, but we're going to talk about it in a second. Basically, what it means is if we have a mean of 0 and a standard deviation of 1, which is called the standard normal, if I wanted to find the probability that something's less than this z, so let's say I wanted z is 1.45, you would go down to 1.4, and then you'd go over to 1.45. This would be your probability. So do you guys see that little tiny number? 0.9265, is that what it is? Okay, so that means 0.9265. This would be the area or the probability up to z equals 1.45. So an area of 1 is representing a probability of 100. So that would be that area there. Okay, so let's do this with different problems. Let's go to the next one. So it says, suppose the mean of the data is 0 and the standard deviation is 1. So that means we're using the standard normal table, this table that you guys have. So calculate the following probabilities. So we want to calculate the probability that x is greater than or equal to 0. So I always draw the picture on these. We're finding the probability that we're greater than or equal to 0. So right there. Now, what would you guys think this probability is? It's not a hard question. 50%, right? 0.5. All right, why do you guys think that? Right, it looks like it's half. This is the standard normal curve is very symmetric. So this is 50%. So let's look at our table. So we have x is greater than or equal to 0. So this is our, we're going to call it our z-score. It's our z-value. Here's where 0 is. Here's 0.00. It's that number right there. Do you guys see the 0.5 on your table? That's the shaded in part until you get to the 0. So this is representing 0.5. So we have this is 0.5. So ours is 1 minus 0.5, which is 0.5. Make sense? Okay. What if I had the probability that x is greater than or equal to 1? Okay, here's 1. We want everything greater than or equal to 1, so we went right there. Okay, so let's look at our chart. So Mason's saying 0.84, and we are going to use that number. Do you guys see where he got that? So go down to 1.0. Here's 1.00. It's this number right here. That's 0.8473. But notice how in your picture it's representing the shaded part up until that number. You guys see? So on our picture, it's representing just this part right here. So right here is 0.8473. Is that the right number? 0.8473. Yeah, mine's like way tiny. I can't read it. 0.8413. Okay, sorry. I'm really confusing you now. So 0.8413. Okay, so how do I find the red part? From 1, right? That's the rest of the probability. So 1 minus 0.8413. So what do we get when we do that? 0.1587. Yep. Okay. Making sense? All right, go ahead and try number 4. Number 4 is pretty easy. You guys can definitely do that. Now, a lot of people in the last class were saying, well, it's just greater than. It's not greater than or equal to. All right, that doesn't matter. So if it was equal to 1, that area is so infinitely thin that it doesn't even matter. So you could say greater than or equal to 1 or greater than 1. It doesn't matter. Okay, so go ahead and find number 4. See if you guys can do that. Anybody have any guesses? Do you guys have 1 minus 0.9773? Okay. What did you guys get? 0.0227. Everybody get it? Making sense? All right, let's try the hard one. So number 3 is the hardest. So number 3, you're finding the probability that your value is between -1 and 1. Okay, so how do I find that? Carolyn, what do you think? Do you have any guesses on what to do? There's multiple ways to do it.
Get, like, the values of each of those and then...
Each of the ends?
Yeah.
Okay.
Wouldn't they both be the same value?
So these two ends, they're going to be the same value. Yep. Is that what you're saying? Subtract from 1, right. So how do I find just one of these ends? Well, what if you found the probability up until 1? Can we do that with our table? Yeah, and we've done that before, right? The probability up to 1 was that 0.8413, is that what you guys told me? Okay, so this is going to be, so it's kind of hard to draw out. So this area right here, all the way to 1, is 0.8413. So this other area is going to be 1 minus 0.8413. Do you guys see that? Which we've already found before. We found that's 0.1587. So we're saying both of those ends have to be 0.1587. So what do I subtract them from? You see the whole thing would be 100% probability. This is like 15% something, and this is another 15%, so we're subtracting them out.
How did you get the 1.1587?
I did 1 minus 0.8413. So that the 8413 was your area all the way up until 1. All right, subtract them out. What do you get? 0.6827? 26. Thank you. Okay, so that's your answer. Okay, making sense so far? All right, well, real life data doesn't always have a mean of 0 and a standard deviation of 1. So like I talked about before, if I asked you the average height of all the females in the United States, it's not going to be 0, right? You're not going to have a mean value of 0. All right, so we would need to find that mean value and change it so that we can use this table. All right, so it says if the mean is not 0 and the standard deviation is not 1, you have to change your graph to fit to this normal bell curve that we've been using. So it says the z-value of the value x in a data set with mean mu. So mu is like, I would say it's a fancy m, but it's also a fancy u. So yeah, if you took off this branch right here, it'd be a u. All right, so it's an m and a u, mu. And standard deviation sigma, so it's like a 0 with a line on it. Oh, like that. Okay, that's called sigma. Yeah, the joke is always, what do cows that know math, what do they say? mu. Makes sense. Not funny. All right. So if you want to find the z-score, so the z-value, to look up on your chart, it's going to be x minus mu all over the standard deviation. So x minus mu over sigma. All right, so let's see what I mean by this. So it says, as the SAT is used for college admissions, the GRE is used for grad school admissions. So let's say we have a sample of the verbal scores and quantitative scores for the GRE, and they're both normally distributed, so they use the bell curve. And they have the means and standard deviations shown below. Mike, you with me? All right, so it says Ellie scored 610 on the verbal section and 700 on the quantitative section. Find the probability that someone scored less than her scores. In other words, find her percentile score. All right, so if you guys take any kind of standardized test, the scores are normally distributed. So there's a mean score, an average score, and everything's pretty even, pretty symmetric. So let's say we're going to do verbal first. Okay, well, what are the different things we know for her verbal scores? We know that for the verbal, the mean, so mu is 470. The standard deviation, sigma, is 121. So mean is m, standard deviation is sigma s. All right, my x value, she scored a 610 on the verbal section, so x is 610. We're trying to find the probability, so 610 is more than 470, right? So it's over here. We're trying to find all the people below her. So if there were 90% below her, this area would be 0.9. Does that make sense? Okay. So we're finding the probability that x is less than or equal to 610. Okay. But if we try to use our chart, we can't use 610, right? That's not on our chart. So we have to change our numbers. So we change this one. This one becomes 0. So my new mean is 0. This one's going to be a z-score. So we change it from x, the original amount, to z, the new thing. And we do that with this formula. So z equals x minus mu over sigma. So x is 610, mu is 470, sigma is 121. What do you guys get when you do that? 1.157. Okay, now on our chart, let's go back to our chart. If that's our z-score, so the z, I go all the way down to 1.1 along here. Oops, so down to right about there. Okay, but then what's my next digit? If I only had 2 decimals? 1.16, right? We're only doing 2 decimals, 1.16. We have to round. So in our case, we go down to 1.1, so we're looking at this row. It's hard to underline. And then we go over, so this is this would be 1.10, 1.11, 1.12. See how it works? So 1.16. So go down there. So it's 0.8, I can't read it. 8770. So we just found the probability that x is less than or equal to 610, which is the same as the probability that z is less than or equal to 1.16 if we were using a z-score. So it's 0.8770. So that means she was in the 87.7th percentile. It's pretty good. But yeah, Ellie's smart. Should we do it for SATs too? All right, so let's do math. In other words, the quantitative, that's math. Okay, so same thing. So do you guys want to try this one and see if you get it? Sure? All right, try this one. I'll pause it. Okay, so when you set it up, so I always draw the curve in. So your mean for the math scores, the quantitative, is 550. Your sigma is 148, standard deviation. All right, you're finding the percentile score if she got a 700. So if x is 700, that means z is going to be x minus mu over sigma. So 700 minus 550 over sigma, 148. So what did you guys get for her z-score? 1.01. All right, so you go back to your chart. Okay, and you look at your chart for 1.01. So it looks like it's 1.01, 1.01 right here. Did you guys get that? Oh, sorry, are these, what's this, 1.01? Oh, yeah, you're right, 1.01, gotcha. 1.01, so this one right here. So 0.8434, what's it say, 0.843? Yeah, I need to zoom in. Okay, so that means that she was in the 84.4th percentile. Good. All right, next step. So this is a normally distributed data set, has a mean of 74 and a standard deviation of 8. So when you hear normally distributed, that means the bell curve. Find the probability that a data value chosen at random is between 66 and 78. So sketch it out. So your mean is 74, so draw that right in the middle. You're going to be between 66 and 78, so that's a little bit closer. So if I was writing out with x's, I'd say find the probability that 66 is less than or equal to x, which is less than or equal to 78. We need to find what that is with z's. So we need some kind of numbers in here. All right, I'm trying to find the red shaded area. So I would probably start with, if I knew nothing else about this problem, I would try to find the z-score, right? The z's. So my z is going to be x minus mu all over standard deviation, which is 8. So on the right, this z-score is 4 over 8, which is 1/2, so 0.5. And on the left, I have 66 minus 74 all over 8, so that's -1. So those are the values we're finding on our chart. Now you can't just look up -1 on your chart. We don't have negatives. How would I find this little bit right here? What was it? You might have been right, I just couldn't hear you. Okay. You can look up the value of 1 and then what? Subtract. You're going to subtract from 1. So if you look up 1 and subtract from 1, does that make sense? Because that would be the same as if I found 1 over here, like that. So I'm going to look at my value from 1 and then subtract from 1 to get this piece right there. All right, so we've done that before. What did we get before? Yeah, 0.1587. All right, so we got that part. Good with that. How do I get this other little part? Yeah, look up to 0.5 and subtract from 1, right? So if I go back to 0.5, 0.500 is 0.6915. And I'm doing 1 minus because I'm just talking about the tail. I'm just talking about the end, right? the other part gave me the 0.6915. That was giving me everything up until 1, or 0.5. All right, so what do we get when we subtract that out? 0.3085. All right, so we're finding the probability. So if I was writing with z-scores, I'd say the probability between -1 and 0.5. And when I do that, it's 1 minus each of the n's. So 0.1587 and then minus 0.3085. Anybody have the final answer? Young, you getting it?
Yes, 0.5.
5328. Thank you much. All right. Good? All right, so let's try to do this one. All right, so a normally distributed data set has a mean of 25 and a standard deviation of 5. So mu equals 25, standard deviation is 5, so sigma is 5. Find the probability that a data value chosen at random is greater than 28. Okay, this won't be too bad. So we're finding the probability that x is greater than or equal to 28. So that's going to be the same as the probability that z is greater than or equal to something. So I need to convert it. I need to find what z is. So if I'm finding z, z is x minus mu over sigma. So my x is 28, so minus 25 all over sigma is 5. So I get 3/5 or 0.6. So I'm finding the probability that my z-score is bigger than 0.6. Okay. Look up your chart. You guys see 0.6? 0.7257, is that what it says? Okay. So that would be the part all the way up to x equals 28. So 0.7257 is all the way there. So in our case, we have 1 minus that answer. $2.743, is that right?